Hi, this is Ms. Fitzmaurice, and this video is about finding the meaning from slopes and areas of a graph. So you probably remember this guy from the first week of school, and I basically just had you memorize this guy. If you have a position graph and you want velocity, then you have to find the slope. If you have an acceleration graph and you want velocity, to do that you have to find the area. This video will address why that's the case. Okay, why is it that, the slope of this graph gives you this quantity? Why is it that the area of this graph gives you this other quantity? And how to figure out, the meaning of those slopes and areas by yourself. Alright, so first we're going to give an example of this by using XVA. So, for example, we're going to talk about why going from velocity to delta x, we need the area. So, what I'm going to do first is I'm going to draw a picture of a velocity graph. So we have velocity, time, and let's say that it's a really boring velocity graph. It just goes straight for a while, and then maybe it goes down to 0. Okay, I'm also going to write the equation v average is equal to delta x divided by delta t, and I'm going to rearrange that to solve for delta x. We can write that delta x is equal to v average times delta t. Okay, if we look at this expression, this is kind of like a base, this is like a height for our graph. Delta t is like a base. And so that's pretty easy to see, that when we're dealing with part of a velocity graph that's just straight across, that v average will be the height and delta t will be the base. If I multiply those together, base times height, that's an area. Okay, what about this weird triangular part over here? Okay, so actually, if you look at any triangle, the average velocity is equal to this height, so like I'm going to say v naught, the big height, divided by 2. Okay, so we could multiply base times height, and so, for a triangle, the area is 1/2 base times height. Okay, in this case it would be 1/2 delta t times the height, which I'm saying is v naught, or I could rearrange that to say that it's equal to 1/2, delta t times v naught over 2, and I know that v naught over 2 is my v average, and I end up back with v average delta t. Okay, so I know that this is my delta x, and once again, the area is delta x. Okay, so it's really a geometric reason that area will give you something meaningful. So you kind of have to look at the equation, look at the geometry of the graph, and decide what the meaning of the area will be. Okay, and so this is going to be true more generally, even if, you have random weird variables. So here I have heart and star. Those are my variables. If there's some sort of equation that says heart times star is equal to, I don't know, happy face squared times angry face, then the area under this curve, okay, because it's our two axes multiplied together, the area under this curve will be whatever's on the other side, so this area will be happy face squared times angry face. Okay, and in this case, we could say that heart is our quote-unquote y-axis. Really, it's better to say that it's our vertical axis, and x is quote-unquote our x-axis, but again, it's really better to say that it's our horizontal. Okay, and when we're multiplying those two things together, that will get us some sort of area. Okay, so let's take a minute and look at this in the context of something you're dealing with right now in our momentum unit. Alright, so here I have a graph of force versus time. What I want you to do is I want you to find me an equation that has both of those things in it. Okay, so hopefully you came up with the equation f of delta t is equal to m delta v. Okay, or you could say f of delta p t is equal to j. Either way, this is our y-axis, this is our x-axis or our horizontal axis. I'm putting these x's and y's in quotation marks, and so we know that the area under this curve will be equal to m delta v. Okay, and I want you to be able to look at an equation, okay, find your two axes, or if they're not already together, rearrange them to see if there is meaning in the area. Alright, so there's one more that I want you to try. Okay, I want you to find me an equation with this in it and tell me what the meaning of the area of this graph is. Alright, so now that you've taken a moment to do that, hopefully you came up with this equation. Okay, and you could tell me that since these are our two axes, the meaning of the area of the graph will be the net force. Alright, so just to summarize, when you see a graph, again, I'm going to use our heart star graph, you should look for an equation that has both of these axes. So in this case, both of our axes would be heart and star in the equation. Okay, if you can rearrange the equation to get your two axes multiplied by each other, then the area under the curve is equal to that stuff. So if you have heart times star equals stuff, then the area will be equal to stuff. Okay, whatever variables might be inside of stuff. Okay, sometimes you can't do that. So sometimes, if you can rearrange your equation so that it looks like heart equals stuff times star plus other stuff. Okay, then this is a linear equation with our star, and the meaning of our slope will be stuff. Alright, so we're going to practice this a bunch on Tuesday. Hopefully this made a little bit of sense. You will need to use it in the free response problem that you're also doing for homework tonight. And I will see you Tuesday.